So, all the businesses on this in this world can be divided into agriculture, production industry, and service industry. So, in production industry, we have raw materials which are converted into work in process. That is, which are in a process of being converted into finished goods. Then we have distribution inventories. That is, the finished goods are in distribution to various locations for sale. And then there are certain maintenance, repair, and operational supplies like A4 size paper, stationery, some other material which is required for repair purpose. So all these material, either raw material, work in process, finished goods, or distribution inventories and MRO, these comes under inventories. So why inventory management? So we need to answer few questions with regard to these inventory items. Which individual inventory item is most important? This is first question. Then how individual inventory items are to be controlled. Then how much to order at one time and when to place an order for the items. And for a clinical laboratory, inventory basically, by inventory we means raw material or reagents for our laboratory test. So inventories are materials and supplies that a business or institution carries either for sale or to provide inputs or supplies to the production process. As inventories are used, their value is converted into cash, which improve cash flow and return on investment. However, there is a cost for carrying inventory, which increases operating cost and decreases profit. So we cannot keep more inventory. We need to balance it. So inventory management is responsible for planning and controlling inventory from raw material stage to the customer, finished product given to customer. This is from my previous lecture on capacity management. As I told you, decision making are of three levels. One is strategic, then tactical and operational. And under these, planning include capacity planning, aggregate planning, master production schedule, and material requirement plan. So all these three, aggregate planning, MPS and MRP, these include the inventories of raw material or reagents in our laboratory. In capacity planning, we have already discussed about the machine and manpower in my previous lecture. Today we will discuss about the reagents and other inventory. So my lecture is divided into two parts. One is aggregate inventory management. This is the overall theory about inventory management. It deals with managing inventories according to their classification and function they perform rather than at individual item level. Then other part of my lecture is on the basis of individual items, and there are these four questions which we have already discussed, that which item is more important, how to control these items, how much to order at one time, and when to place an order. So as we know that inventory is associated with cost, it is associated with carrying cost and other costs which we will discuss later. So if we want the customer service to be high, then there is high inventory cost. If customer service is low, the service level to the customer, we will discuss these later in my lecture. Then we have low cost of inventory. So we need to balance these two. So the goal of inventory management is to maximize customer service and to have low cost plant operation and to have minimum inventory investment. So we need to balance these two things, customer service and cost of inventory. And this will be clear after my lecture today. So why is the need for inventory? So there are two scenarios. One is if demand is predictable and stable. So if we know that we have a demand of 200 blood glucose tests every day, then we just need to order 200 blood glucose reagents every evening and we need not have an inventory. So if demand is predictable and stable and relatively constant over a long time, large enough to justify economically setting up system, then we can use line flow system or just-in-time manufacturing. So this is just in time. Whenever we need to do the test, we order the reagent. But this is only possible when demand is predictable and stable. If demand is unpredictable, not sufficient or not stable, then we need, in case of production industry, we need to produce in lots or batches in workstations, and this generate inventory. So hence the basic purpose of inventory is to decouple supply and demand. So we can decouple supply and demand because we maintain the inventory of raw material or reagents in case of clinical laboratory. So first part of my lecture, aggregate inventory management. So this includes classification of inventory. Inventories can be anticipation inventory. This is in anticipation of future demand. If we are in charge of a clinical laboratory and we anticipate that there will be a dengue outbreak in few couple of months, then we can acquire the reagents of dengue serology, and that is known as anticipation inventory. Then fluctuation inventory or safety stock. This I will discuss later in my lecture. Then lot size inventory or cycle stock. This is to take advantage of quantity discount. Sometimes the suppliers of reagents or raw materials, they give discount. So to get the benefit of that discount or to reduce the shipping cost, clerical cost or setup cost, we have the lot size inventories. Then we have transportation or pipeline inventory. This is only for production industry. This is not for service industry, and our clinical laboratory is a service industry. Then we have a hedge inventory, and then we have material, repair, and other inventories. So, inventory increases operating efficiency. How? Inventories allow operations with different rates of production to operate separately and more economically. So, if we have inventory, then we can combine two processes of production which are of different rates, because one will produce faster, the other will produce slower. So, we have inventory in between. Then inventories allow level production. So, these are all applicable to production industry, but we need to understand these so that we know better about inventory management. So if the seasonal demand is fluctuating, then we can the entire month, all the months of the year, we can produce a level amount of finished products. So inventory allow level production. Then inventory allow for longer production runs, and inventories allow manufacturing to purchase in large quantities, as we have discussed about discounts and shipping costs. So these are all ordering costs per unit and quantity discounts. So what are the factors affecting inventory investment? So first factor is customer service. This we have already seen, that lower the inventory, the higher likelihood of stock out and lower level of customer service. We have seen that these are inversely related. Then the higher the inventory level, higher the customer service will be. So then cost associated with changing production levels. So excess equipment capacity over time, hiring, training, layoff will be higher if production fluctuate with demand. This we have seen in my previous lecture, that we need to manage the capacity. Then cost of placing orders. Lower inventories can be achieved by ordering smaller quantities, but this will result in higher annual ordering cost, because whenever we order, there is some kind of ordering cost associated with it. Then transportation cost for production industry, the goods moved in small quantities cost more as compared to the goods moved in larger quantities. Then carrying cost and stock out cost. So all these things, these are the factors which affect inventory investment, and we consider all these factors in inventory management. So what are the costs associated with inventory? So first cost is the landed price, and this includes cost of the item, transportation cost, custom duties, and insurance. So we are talking about like bulk purchasing of the raw material from outside the country. Then we have carrying costs. So carrying costs include all these. One is the capital cost, because we have locked our capital in inventory. We could have used that money for other purpose. So that is known as capital cost. So if we have lot of inventory, then we have lot of capital locked in that. Then we have storage cost. We need electricity sometimes to store our reagents at near zero or sub-zero temperature. So we have storage cost. Then there are risk costs, which include obsolescence. That is the reagents, they soon expire. Then there is obsolescence cost. Then damage to our inventory. Then pilferage from our inventory, and deterioration because of exposure to wrong temperature or sunlight, etc. So these are the risks associated with inventory. Then we have ordering cost. Ordering cost include order placed with supplier and order placed within the factory. So this is about production industry. Sometimes one section of a business entity order from other section of the same business entity. So these are those costs. Then we have stock out costs. These are very important. So if we don't have reagent for, let us say, if we have stock out of blood glucose reagent and a customer and a patient comes with a request for blood glucose level, then we need to ask customer that please come tomorrow. We don't have reagent. So that is known as back order. So there is back order cost. Sometimes we request him to come tomorrow, but then the customer says, no, I will get my test done from some other laboratory. So that is lost sale. We have lost the opportunity of our sale. And sometimes customer, they forever, they move to some other laboratory. So that is lost customer. So these are three important costs which are associated with stock out of our reagents. Then there are capacity associated costs. These we have seen, we have discussed in my previous lecture. These include overtime, extra shifts, hiring, layoff, training. This I have already discussed in my previous lecture. So these are the costs associated with inventory. Now the second part of my lecture is item inventory management. So these include various questions, and these 4 questions are very important. Today we will discuss these 4 questions. So let me repeat these. Which individual inventory item is most important? How individual inventory item are to be controlled? How much to order at one time? How much reagent we need to order at one time? And when to place an order? So first question is, what is the importance of inventory item? For this, we use a calculation known as ABC classification. So ABC principle is based on observation that small number of items often dominate the results achieved in any situation. So this is on the basis of a law known as Pareto's law, and it was after the Pareto. So it states that about 20% of items account for 80% of dollar usage or monetary usage in whatever currency. So 20% of items are important because they account for 80% of our money expenditure. So these 20% are group A. Then 30% of items account for 15% of the expenditure. These are in group B. And group C are about half of the items which account for only 5% of our expenditure. This is on the basis of Pareto law. This law is applicable to the customer relationship management, is applicable to economics also, and it is applicable to our clinical laboratory also. So these percentages are approximate and should not be taken as absolute values. And this type of distribution can be used to help control inventory. So what are the basic broad steps? So we establish the item characteristics that influence the result of inventory management. And usually the characteristic is expenditure, that is the dollar usage. But there may be other criteria which can be used like unit cost, scarcity of material. So there may be other characteristics by which we can arrange the items in the descending order in the group A, group B and group C. So we classify the items into groups on the established criteria. Then we apply a degree of control in proportion to the importance of the group. These are the steps in detail. So this is the actual steps which we use in our clinical laboratory. We determine the annual usage of each item. Then we multiply the annual usage of each item by its cost to get the total annual dollar usage. So we convert the annual usage in number of test units to the monetary unit or the expenditure value. So the second step is conversion of the units, number of tests to the monetary unit. Then we list the items according to the expenditure or annual dollar usage. Then we calculate the cumulative annual dollar usage and cumulative percentage of items. Then we put the items into group A, group B and group C. So it will be more clear when I give you an exercise. So the second question is how individual items are to be controlled. And this is actually from ABC classification. The answer is very clear. So for A items, these are high priority items. We need to have tight control, including complete, accurate records, regular and frequent review by management, frequent review of demand forecast, and close follow-up and expediting to reduce lead time. So this is how we control the Group A items. Then Group B items are medium priority items. For this we apply normal control with good records, regular attention, and normal processing. Then we have Group C items, which are lowest priority. For these, we have a rule that we can acquire them in plenty because they just account for 5% of expenditure. So if we order twice the amount, there will be no loss. There will be no capital lockout in inventory. So this was about how to control them. So in brief, we have plenty of low value items, that is C items, and we use money and control effort saved to reduce inventory of high value items. So we need to focus more on A items. So we save time from B and C items. Then the next question is how much to order at one time? And the answer is by the simple calculation of economic order quantity. So there are some certain assumptions which need to be fulfilled before using economic order quantity model. The assumptions include that demand is relatively constant and known. This is first assumption. We should know the demand beforehand by a very almost accurate forecast, and it should be relatively constant. Then the item is produced or purchased in lots or batches and not continuously. So we need to purchase in lots. Then order preparation cost and inventory cost are constant and known. So we should know beforehand what is the ordering cost and what is the inventory carrying cost. Then only we can calculate the economic order quantity. And replacement occurs at once. That is, it is delivered at once by the supplier. So this is the actually little mathematics about it. This will be clear when we do the exercise. So this A stands for annual usage in units, and Q is order quantity in units, S is the ordering cost, C is the unit cost, then I is the carrying cost. So I is in fraction, that is 5%. So carrying cost is usually expressed in form of percentage. That is the carrying cost of carrying an item is about 5% or 10% of the unit cost of the product. So annual ordering cost is given by this equation, and annual carrying cost is given by this equation. And the total annual cost is the annual ordering cost plus annual carrying cost. Now, this is a very beautiful graph which says that the carrying cost increases as we increase the lot size. If we increase the lot size of order, so if we order in a larger lots, then we have large inventory. So we have lot of carrying cost. So if the lot size is more, we have more of a carrying cost. If we order in smaller quantities, we need to order multiple times. So we have lot of ordering cost. So this graph is of ordering cost. So if we have a big lot to order, then there are few orders per year. So we have a lesser ordering cost. So the total cost, which is the combination of these two, is lowest when these two curves intersect. So if we equate these two, terms, then we have the economic order quantity because the total cost is lowest when these two are equal. When the carrying cost and ordering cost are equal, then we have a lowest cost, total cost. So that is our economic order quantity. So here in this graph, 200 units is economic order quantity. So this is further mathematics. So after equating these two, we can calculate this equation for Q. Q is the ordering quantity. So Q is equal to square root of 2AS divided by I multiplied by C. C is carrying cost and I is the unit cost. So this will be clear when we do an exercise. Then practical considerations when using economic order quantity. So as we have seen, there are few assumptions So this is, I'm skipping this because this is directly related to our assumptions. Then a little bit of safety stock. So safety stock is intended to protect against uncertainty in supply and demand. So uncertainty may occur in two ways: quantity uncertainty and time uncertainty. There are two ways to protect against uncertainty: carry extra stock, that is known as safety stock, and order early, that is known as safety lead time. So whenever we place an order to supplier. Let us say we place an order of blood glucose reagents, 200 units to a supplier. The supplier will not supply same day. He will supply after a day, after 2 days, after 3 days, or after 1 week. And that time period is known as lead time. So if that lead time is uncertain, then we need to order early. And this is known as safety lead time. And the other thing is safety stock. I will give you an example. Let us say if on an average our clinical laboratory handles about 250 patients of blood glucose testing, then the average number of units of glucose reagents required is 250. But this is average. It is associated with standard deviation. And that standard deviation determines the safety stock. The more the standard deviation is, more is the variation in number of our patients of blood glucose in this example. So we need to keep more safety stock because variation is more. It will not be average 250 every day. Someday it will be 300, someday it will be 350 patients. Then we will have the situation of stock out. So we need to carry an extra safety stock, and that is equally proportional to the standard deviation of the number of patients of blood glucose. So this was about safety stock and safety lead time. So this is a little bit about safety factor. The service level is directly related to the number of standard deviations provided as safety stock, is known as safety factor. So in statistics, we teach our students that the about 95% of observations, they lie within 2 standard deviation. This is a well-known statistical fact that 95% of observations, they are within 2 standard deviations. So if we need to satisfy 95% of our customers, then we need to keep the reagents about mean plus 2 standard deviations. That is nothing but the safety stock. And this number 2 is safety factor. So here is the formula for safety stock. This will be clear when we do an example. This is a service level. So because this is one tail, in two tail distribution, the 95% is 2 standard deviation. Whereas in one tail distribution, the 95% is 1.65 times the standard deviation. So this is the safety factor. This table is already given in textbooks. So if we need to satisfy 99% of our customers, then we need to carry 2.33 times of standard deviation, the number of reagents which we need to carry as safety stock. So this is the multiplication factor or the safety factor which we need for So we multiply the standard deviation with safety factor to calculate the safety stock. So here SS is safety stock, this is standard deviation, and this is safety factor. And safety factor here for 99% is 2.33, and for 95% is 1.65. And this is if we have standard deviation for forecast interval, then we need to convert this into standard deviation of lead time. So this will be clear in exercise later. Then the next question is when to place an order. Now we know which item is important. We also know how much to order. Now when to place an order. So these are the options. One is lot for lot. So this is order exactly what is needed, no more, no less. And this is used in just-in-time manufacturing environment. So this is not possible for our clinical laboratory because our demand is not constant, and it is difficult to practice the just-in-time concept in a clinical laboratory. So lot for lot is not possible here. So the second option is fixed order quantity, and here we specify the number of units to be ordered each time an order is placed, and then is fixed time system or periodic review system. So there are these two systems I will describe in detail. these two systems, fixed order and fixed time. So, so the fixed order system is known as order point system, and fixed time system is known as periodic review system. So there are these two systems which we can by which we can determine when to order. So the first system is the order point system. So here I will describe you using this with the help of this graph. So let us say if we have ordered a particular quantity of reagents at this point of time. So these reagents are continuously used over the period of time. So this is the timeline, x-axis. So this is how our reagents are depleted. And here an order point is reached. And whenever this order point is reached, we will order. So this is the order point system. So first system is order point system. We calculate the order point, and whenever this order point is reached, then we order. But when we order, the supplier will supply after 2 or 3 days. So there is further depletion of our reagents, and we reach the level of safety stock. So now the thing is, how much reagent we should have when we reach the order point. That is, the order point is equal to demand during lead time, that is demand during this period. This is the lead time. Demand during this period, that is difference between this and this. So demand during this period plus the safety stock. This is the safety stock. And the formula for safety stock we already know. And demand during lead time is nothing but the mean or average number of reagents you require per day. That is the demand during the lead time. So if the lead time is 3 days, then we keep then the DDLT or demand during lead time will be 3 multiplied by the mean or 3 times the average per day, because it is for 3 days. So this is the order point. So this is the concept of the order point system. Here the order point is achieved at variable time points. Sometimes the fall is not very steep when there are few customers. Then it will not fall very steep. It will fall gradually, and the order point will reach a little later than the previous order point. So the time is variable here. Whereas in the next system or the periodic review system, we review every month or every week or every similar period we review, and we assess how much quantity we have, and then we order. And how much to order? Here we order till a target level. So here we decide a target level, and this is the formula for target level. It is little bit of more mathematics, but this is very important for day-to-day practice in our laboratory. So how to calculate the target level? So this is the formula for target level, and this include the demand during lead time, demand during review period, plus the safety stock. So this is very simple. So we keep the margin for the review period. If review period is 3 weeks, we keep the stock for 3 weeks. If lead time is 3 days, we keep the stock for 3 days, plus the safety stock. So this formula is very simple. So the target is equal to demand during the review period, demand during the lead time, plus the safety stock. So this is further modification of this equation. And the quantity to order is variable here. So, but these time periods are, these are equal, because we are assessing at equal point of period of time, that is after every week or after every month. This practice is we follow in our hospital. We review after every month the status of our reagents, and then we order the reagents. So this practice we follow practically in our laboratory. So these time intervals are equal, but the order quantity is not equal. The order quantity is given by this formula. Now, who will keep check that when order point is reached? Who will say this sir, the order point is reached, now you order? Who will tell this? How to keep check of this? So this is our final question here. Then for this in production industry, we have this system, and we can also use in our clinical laboratory. So there are these 3 methods of which we can know that order point is now reached. So order point is right. Let us revise. This is the order point. But who will say that this point is reached? And the answer lies in these 3 systems. You can use any of these 3 systems. and these will tell you when the order point is reached. So one is the 2-bin system. Here we do the quantity of item equal to the order point quantity set aside, and it is not touched until the main stock is used up. So the order point quantity is kept aside, and we use other reagent. When the other reagent finishes and we are about to use the order point stock, then we know that order point is reached. So this is very simple. By this we know that order point is reached. This is very simple. No need to take care of anything. Just divide the reagents into two: the number of stock for order point and the other stock. So you use the other stock. When other stock is consumed, then we know that order point is reached. Then Kanban system. So Kanban system, it is a card-based system. So this will be clear by this. So if there are these, this is an example from a manufacturing industry. So we have workstation 1, workstation 2 here, and the gray cards are the the moving card, and the black cards are the production card. So this is the equilibrium situation. So whenever we have a demand for a finished good, then we use this container of finished goods. So when we use this container, this production card is free. Whenever the production card is free, we know that we need to produce more. So what we do is we produce more. So the next step is here. We produce more. So container from here goes to here because we have produced this raw material to finished goods. Then the card, which is the moving card, now it is free. So when moving card is free, we need to move the container. So we move the container from here to here because moving card was free in previous step. So we move the container. Now this place is empty. We have this card of production free. So we will produce. Whenever we produce, then we have a moving card free. So this is the 2-card system or Kanban system which is used in production industry. We can use this with little modification in our clinical laboratory. Then we have a perpetual inventory record system. This is the actual system which we use in our hospital for identification of the order point when the order point is reached. It is nothing but the live record of everything. So we keep a daily record of how much reagent is consumed, and because of this perpetual inventory record system, means we keep on recording it on time every day, or in every batch we just update our reagents. That is how we can know that the order point is reached. So this practice we follow because the other two previous systems are difficult to apply for a clinical laboratory. So we follow in our laboratory perpetual inventory record system. Although it is little cumbersome, but we use this system to identify the order point. So there are certain calculations. So I'm not going into much detail. Anyone, if he or she is interested, then they can see the recording of my lecture. Now it is time for exercise.
A company is manufacturing 10 items. The accompanying table shows you the usage and the unit costs along with the annual dollar usage, which is obtained by multiplying the unit usage by the unit cost. Now classify these items as per the ABC classification that sir has explained.
So you need to identify which of the items from number 1 to number 10, which number of items are important, which are in A, which are in B, which are in C. So these items are coded into 1 to 10 numbers. These are code numbers for items. These are name of items, let us say. The first column.
Actually, you cannot decide the classification by just looking at the annual dollar usage, right? You first have to calculate the cumulative usage, right? And then calculate the cumulative percentage usage.
So this is how we classify as per ABC classification. So here you can see that as in this graph, there is rapid rise in graph. This is as per Pareto law. So Pareto law states that this 80% of the result is because of these 20% of items. And this Pareto law is we have seen that it is applicable in this example also. So the 80% of value is because of 20% of items. So these two items are item number 2 and item number 5. These are in A. We have kept them in A because this is the cumulative usage, and about 80% of accumulation is by these two items only. And then there is gradual increase. Then there is not rapid increase. It is the gradual increase because the contribution of these items is very low as compared to these initial two items. So these are in B and these are in C. So we can order plenty of item number 10, 9, 3, 6, and 7. We can order them plenty. We need not worry about the C items. We need to be very careful about A and B items, and importantly A items, because the more of our money will be locked in this A item if we keep more inventory of this A item. So this is about exercise 1.
Now coming to exercise 2. Now assume that you are in charge of the biochemistry section of a clinical laboratory and you need to order reagent for the blood glucose test. And the given supplier A, says that he would take 3 days to supply the material to you after you have placed the order with him. And on an average, you are receiving about 150 blood glucose tests in your lab. This is a daily average with a standard deviation of 5. So you have to calculate the safety stock of the reagent to be maintained in your laboratory at all times to avoid a stock out. So this is what sir had explained to you, how to calculate the safety stock.
And for present example, you calculate at the level of 95% customer satisfaction.
So I'll give you the values again. Your daily load of blood glucose test is 150, standard deviation is 5, and the supplier would take 3 days to supply the material to you. So what should be the safety stock? How many tests, reagents for how many tests should always be available to you as a buffer? Now, as sir said, first we calculate the standard deviation of the lead time interval, which is standard deviation of
Forecast interval.
Forecast interval.
Forecast interval here was 1 day. Because we have this daily standard deviation of 5. So it is 1 day here. And the lead time interval is 3 days. So first we calculate the standard deviation for 3 days. What is the standard deviation for 3 days? What is the variation in 3 days? So that was 8.66 number of tests. So 8.66 requests is the variation which we will encounter in those 3 days of lead time, because we will get the reagent after 3 days. And the safety factor is 1.65 because we need to cover 95% of our customers. We will refuse only 5% of customers. We can keep the level 99% also. But for this example, we have stated as 95%. And of course, we will refuse 5% of our patients. For satisfying 95% of patients, we need to keep a stock for 15 number of tests. So 15 number of blood glucose reagents for 15 tests, we need to keep as a safety stock forever for our laboratory. We will not consume that stock in any case.
Here you have to decide the order quantity for reagent for blood glucose test again using the economic order quantity method. And the data that is provided to you is that the annual usage is 45,000 tests. The ordering cost per order is rupees 2. Unit cost of your reagent is rupees 5. And the annual carrying cost rate as a fraction is 5%, which translates into 0.05. So using the economic order quantity formula, calculate the order quantity that you have to place at one time. So this is the formula. You have to use the EOQ physical units. The formula for EOQ physical units to calculate the order quantity.
These are the abbreviations. A stand for annual usage in units, and it was 45,000 here. Q is what we need to calculate here. S is the ordering cost, which was 2 rupees, I think, in this present exercise. C is the units cost, which was 5 rupees here. And I is the annual carrying cost, which was 5% in this example. So just put these in this formula and just calculate. It is very simple.
So A is the annual usage, which is 45,000. S is the cost of ordering cost per order, which is rupees 2. Small I is unit cost of that reagent, which is rupees 5. And C is the holding cost or carrying cost, which is 0.05. So solving this formula, we have square root of 7,20,000, which comes to 848.52. Say 849, you can round it off to 850 units. So reagents for 850 tests have to be ordered at one time using the economic order quantity.
So this much quantity we need to order every time, so that we have the balance of ordering cost as well as carrying cost.